We've got a 2008 Honda CRV towed in for intermittently not starting. When it got here, it started, but it would kind of hesitate at times, and eventually to the point where it wouldn't start. The customer did say, I believe another shop had installed a starter. It made no difference. It's still intermittent or a complete no start. So we're going to show you some of the things we looked at, what we found, and what the problem is. So to show you what it does, we'll come in. And you get that buzzing noise, but it doesn't. No start, no starter operation. So this here is the inline connector that comes from inside. It's the starter signal switch command that goes to the solenoid. So we will check the starter operation from here down by manually feeding 12 volts. Okay, so by doing that, from this point down, we know that the big B plus cable to the starter on the stud is providing enough voltage and amperage, and that from here down to the solenoid is also providing enough of the B plus, and also it shows that our main ground for the starter is good. So from here down, we don't need to do any further checking. Okay, so now what we are going to show is now we're tapped in this way on the meter to see if we get a good 12 volt source. I'll turn the key there. So we've got what we are seeing as a good feed. I'll do it again to show you. There's the volt, and one thing, you don't hear that relay buzzing. I'll let go. There we go. So right now, if we turn the key from the ignition switch, it feeds voltage down to that connector that's supposed to send the 12 volts down to the starter solenoid, which should activate and turn the starter. Okay, so now we're plugged back in on the connector. We are tapped in and see what we get there when cranking the same way. And not enough voltage, and you can hear that buzzing. We'll check one more time. So there we go. Different reading than before when it was unplugged. So here is a diagram breaking down how the system is laid out and how it works. So we've got our battery voltage. This is the main stud, which we know is good. We know that ground is good. And this is that line that we are or have been looking at. There's that connector. So B plus comes here through the underhood fuse box, through the under dash fuse box to the ignition switch on the white wire, and comes out. Obviously, when we go to start, it'll tie in that B plus, send it down on this yellow wire, which feeds two things, this point and this point. When it comes here, it'll ground through the park neutral switch on the engine, and it'll activate the solenoid, which will close, and then that will bring voltage down to the starter. When we unplugged here and checked voltage on this end coming from this direction with the meter, with this unplugged, we saw 12 volts on the meter. The only way to see 12 volts here is for that relay work side to be grounded to close this to send the voltage through. Once we connect this portion here is when we drop voltage, and when we were pierced we saw less than 1 volt present here. So what I want to look at is the B plus points on this white wire, see what it's getting fed here, and then the B plus here on this yellow, basically in and out of the switch. Okay, so first thing that I am checking is this white wire at connector D1 that's coming out of the fuse box that will go to the ignition switch. That's going to be hot all the time, and that's where I'm tapped in. And since it's constant, there's 12 volts present there now. Next, I will check C1, that yellow wire, which is actually connector next to it. That yellow wire there in the middle. Okay, so I'm in the yellow wire, and that should only have power when the ignition switch connects those 2 points. We'll watch the meter. And we've got 4 volts present, and you hear the relay buzzing. So 4 volts. So we've got 12 that came in, goes through the switch, through the contacts. Coming out at this point, we have 4 volts. And kind of just to reiterate and show you, if we unplug that, still on the yellow wire there, we turn the key into start, we get the full 12 volts on that yellow wire. If I let go, there we go. So what basically is happening, so at that point, with this unplugged, we got 12 coming in, 12 coming out to feed these 2 items. But if this one's unplugged, we're only feeding 1 item, and we're not dropping any voltage. Once we connect this and load it with a second item, which would be a major, the starter solenoid, we then drop voltage down to 4 volts here. And at this point, we get less than 1 volt. We got 4 volts here, and we've got 12 volts here. We are experiencing and seeing and having a voltage drop from in and out when we have to feed 2 items, let's call it, and it's being dropped in the switch, and it cannot handle feeding 2 loads because of the voltage drop, which goes basically from 12 volts to 4 volts. 4 volts cannot feed the relay work side and send to the starter relay. And so to sort of prove that out, all we can do is manually become the ignition switch and tie the yellow and the white together. That'll help prove out the drop, and that, again, everything else down the line is good, including the ground here. That could be questionable if that could be causing a voltage drop as well. So if I put the key in, put it in the on position, and I'm still in the yellow wire, but I will go touch the white wire, which is the feed coming in. It's gonna be hard to capture that, but let's see. There we go. At that point, we prove everything else is good down the line. So we went 12 volts this way. Disregard the switch. We had 0 voltage drop from here to here because we basically just looped it, and that was enough to feed both items loaded. We're dropping voltage coming from the in point, the out point, due to the contacts in the ignition switch. So the problem with this Honda no start or intermittently starting issue is not a starter, or not what sometimes would be a common main ground, or not even a starter relay. It is an ignition switch, which this is the new one we will be putting on, a genuine one. It is dropping voltage through the contacts, which cannot handle the load of supplying 2 items. This is just one way of checking this. There is voltage drop testing, loaded testing you can do with light bulbs and everything. And this is just the way I'm showing, visually be able to see it with a meter. And yes, if you don't test further, the meter can get you lost because it showed us 12 volts here. That's an unloaded 12 volts. But for me, I just use it as a visualization and continue doing the testing to still get the same answer. But yes, the best way is to do a loaded test. This is just another form or way to go about it, and we still get to the same end result with some visualizations. Okay, switch is installed. We'll just quickly get you a shot. There you go. There's the problem. Voltage being lost and dropped from the electric portion of the ignition switch. And lastly, just to prove out or just internally show you what was going on, we obviously have got colored portion there, and then if you look at this point, that point, compared to this point here, there's a lot of buildup, and we're losing good contact, dropping voltage through this wore out and contact points that just are not touching well. In the past, on my personal vehicle, you can get away with cleaning all of these metal portions and this side as well. And I think I actually had to maybe spring out a little bit to have better contact. But I got away with doing that on my personal vehicle. Obviously, this is a customer. We put in a new genuine one, but sometimes you can get away with saving your vehicle or your ignition switch and getting it started by cleaning these contacts, and you should not drop voltage then. So hope that's helpful and insightful. If it gets you out of a jam, other than that, the true fix is replacing the old switch. But that way you have 2 options here that will get you up and running.